Greetings, guys. Let's talk about solving nonlinear inequalities. You've probably already talked about linear inequalities. Those are the ones that you can just solve for x by getting x by itself because it's just x to the 1 power. Nonlinear implies that it's going to be something with x to either a higher power or a radical or a negative power, which means x could be in the denominator. Any one of those, the complexity goes up so much that we don't really want to learn several different other methods. Instead, I'd rather have one method that just always works for all of the different inequalities. And that's what we want to talk about here. Basically, I'm going to take advantage of sectioning and testing inequalities here. Okay, so here's the process by which we're going to do this. First of all, you always want to have 0 on one side of your inequality. Whatever side's easier or makes more sense to you, it doesn't matter. Next, if you can factor things, it helps in the solving process and makes it more quickly, readily able to find some of the numbers that we're interested in. Okay? But if not, you can just move on to step 3. Okay? Step 3, it's like a pretend step, right? I'm going to pretend that it's not an inequality for a moment, and I'm going to use the equality for just a moment, meaning I'm going to be finding single values, not whole intervals. And what those values are going to do is they're going to act as separators in my finding process, okay? After you find those, step 4 is to actually draw out the number line so you can visualize this. Put those separators in order on the number line, and then that'll make little sections, little intervals on the number line. And step 5 would be you're going to test each one of those. And the way you test is you just take a number from each interval and put it back into the original inequality that you're trying to solve. Okay? So let's get an example here while I've got this going. So I'm starting with this inequality here, right? Step 1, I'm going to get 0 on one side by subtracting 45x from both sides. So, then factoring if possible. So I can GCF a 5x out. That's going to leave me with x squared minus 9. And I can actually factor x squared minus 9 again. Okay, so now I've got it all broken down and everything. I'm going to do the step 3 portion where I pretend, right? I'm going to pretend to solve the equals version. So 5x, x minus 3, x plus 3 equals 0. And these are all multiplied out and equal to 0. Those are quick and easy solutions. Here I can get that x is 0. Here I can get that x is 3. And here I can get that x is negative 3. And all I'm doing is I'm setting each one of those pieces equal to 0, much like we did way at the beginning of the course, right? When you're solving something equal to 0 and it's just factors, you could set each piece equal to 0. And that's how I'm getting those particular solutions. Okay, well now those numbers are my separators, meaning I'm going to draw a number line. And I'm going to put these numbers in order on that number line. So negative 3, 0, positive 3. And it doesn't really matter, about where you put them as long as you put them in order. And this is just a visual thing for me. It works best for me. You can kind of tweak it to make it work for you as well. But what I do is I just kind of separate out some sections here. And that's because what I'm going to do is I'm going to put some work testing each section. Okay? So let's see. In this first section right here, I've got the interval from negative infinity to negative 3 here. right? All right, well, I can pick any number I want in that section, and what I'm going to do is I'm going to take whatever number I pick, and I'm going to test it in the original inequality. So it's just like you would do with any other math problem when you're testing your answer, except now I'm actually using that mechanism to help me flesh out which one of these sections actually is part of my answer, or more than one section, right? It could be any of them. So here we go, negative infinity to negative 3. I can pick any number I want. Maybe I'll pick negative 4, right? I'll just put x equals negative 4 to remind me what I picked. And then I'm going to plug negative 4 in. So 5 times negative 4 cubed is less than or equal to 45 times negative 4. And then we just work it out and see if it's true or false, right? Negative 4 cubed is negative 64. Times 5 would be negative 320. Less than or equal to 45 times negative 4 is going to be, let's see, 160 plus 20 is negative 180. Like so. Okay? That happens to be true. Which means this interval right here, negative infinity to negative 3, that whole interval represents a piece of my solution set. Okay? Next section, I can pick anything between negative 3 and 0. Anything we want between negative 3 and 0. So maybe I'll pick negative 1. It doesn't matter what you pick as long as it's in that interval. You could pick negative 1.2745. A little bit less advisable because it takes you more time to calculate those, but you get my point. Okay, so I'm going to plug negative 1 in. 5 times negative 1 cubed less than or equal to 45 times negative 1. That's just going to give me negative 5 is less than or equal to negative 45, which is false. So I won't be using this interval in my answer. Okay? So on and so on, right? Pick a number between 0 and 3. Right? On the interval 0 to 3, maybe I'll pick x equals 1. Right? If I plug in 1, I'm going to get 5 less than or equal to 45. Right? Because it's times 1 times 1, which is true. All right? And then in the last section here, anything from 3 to infinity. So maybe I'll pick x equals 10, right? 10's easy to plug in. I probably should have done negative 10 over here, but it doesn't really matter as long as you pick a number in the interval. So in this case, 5 times 10 cubed less than or equal to 45 times 10. 10 cubed is 1,000. So this is 5,000 less than or equal to 450, which is completely false. Right? So I won't be using this interval either. Okay, once you've tested all the sections, you can write your final answer. Right? So my solution set is going to be anything from negative infinity to negative 3 union with 0 to 3. Okay? Now wait. One extra little thing that we got to consider. There was an equal to underneath this inequality. So that means I can include any place where x was also causing the 0, not just being less than. Okay? Well, we already saw that equal to 0 happens on all 3 of these locations, and none of them cause division by 0. So that means instead of parentheses on all of these, I can actually use brackets, because that will cover the equal to portion here. Okay? Here are 2 more examples of this method. Right here I've got a quadratic inequality. Okay? So step 1, I'm going to get 0 on one side. Now I prefer to have my squares, like the highest power, positive. So I'm going to add 3x squared and subtract 2 to this side. Like so. Okay, from here, factor if possible, right? And you notice if you multiply the AC method, 3 times -2 is -6. There are actually two numbers that add to 5 that multiply to -6. So that means this is factorable, right? Like so. -1 and +2. Okay, so I've got my factorization. And then remember, for a moment, we pretend that we have an equals 0. So I'll just be solving the 3x minus 1, x plus 2 equals 0, which means I'm just going to be getting each of these equal to 0. So I'm getting x is 1/3 here, and x is -2 here. Okay, once I've got those two, I'm going to set up my number line, my separators. I only got 2 of them this time. And put them in numerical order, don't forget. Right? -2 first, then 1/3 in this case, because that's the way they would appear in the number line. So now I'm going to test each section. This first section right here is -∞ to -2. And I can pick anything in there I want to test. So how about x equals -10? That's usually a pretty easy one to plug in, right? So I'll have 5 times -10 is less than 2 minus 3 times -10 squared. So that's -50 is less than 2 minus 300. Is -50 less than -298? No. False. So I won't be using that interval, right? Next, anything between -2 and +1/3. I'm going to pick 0. Anytime you can use 0 and it doesn't cause some sort of division by 0 or anything like that, you're good to go, right? So, okay, here with this one, I'm just plugging in 0. 5 times 0 is 0, less than 2 minus 0, right? That's just going to be 2. And 0 is less than 2, that's true. So I will be using that interval. Okay. So then, in this last interval, I have anything from 1/3 to infinity. Why not pick 10, right? Again, that's a pretty easy one to plug in. So I'm going to get 50 is less than 2 minus 300 again, right? That's less than the 298, like that. And of course, 50 being positive is not going to be less than a negative number. So that, again, is false, and I won't be using that section. Okay, so let's write our solution set. There's no equals this time, right? So then I won't be using brackets is what I mean. My solution set is then this one, -2 all the way to +1/3. Okay? Now if you want to get technical, and you want to write out a solution set in mathematical terms, sometimes you may also see this, x with a little e. And all that means is x is an element of this set of numbers, of this interval. Okay? Sometimes I throw it out there, sometimes not. It just depends on which program you're using and which, instructor you have. Okay. Now, this one seems like it might be the same kind of example because it's a quadratic with an inequality. But what's different is this one's not going to be factorable. Or it could also be in the category of maybe you missed the factorization or couldn't see it. Anyway, I want to show you how sometimes the step 2, the factoring part, isn't 100% necessary. If it's something that you can still solve in step 3, then you're okay. In this case, I get step 1 going on, which is get my 0 by subtracting 2x from both sides. Okay, and then 4 times negative 3 is negative 12, but has to add to negative 2. And either nothing will add or I can't think of anything, right? One way or the other, this ends up not being factorable in my mind. It's not factorable, but okay. So then I skip over 2 because I can't factor, and I go to step 3, which is solve equal to 0 portion, right? Okay. So I'll be solving this equation, and that's okay. It's a quadratic equation equal to 0, which, even though it's not factorable, I can still solve. I have the quadratic formula to help me. Let's do that. X equals negative negative 2 plus or minus square root negative 2 squared minus 4 times negative 3 all over 2 times 4. Okay. So let's see, I got x equals 2 plus or minus square root of, I have 4 plus 48, so 52, all over 8. We can simplify that a little bit, right? 52 is 4 times 13. So this can be 2 plus or minus 2 square root of 13, because the square root of the 4 is 2 over 8. And I can do 2 over 8 in both places, which means I can reduce all the way around. Divide everything by 2. So my two solutions here I'm getting are 1 plus square root of 13 over 4 and 1 minus square root of 13 over 4. And you can punch those up and get the decimals and stuff like that, but let's keep accurate for a moment. To make the values known on here, I'm just going to label this one A, and I'm going to label this one B. Okay? Just to make it quicker to write while I'm working the problem. Step 4 is I'm going to take these numbers and use them as separators, right? So here's my number line. You can tell that A is going to be a smaller, well not smaller, a lesser number than B because it's the minus, right? 1 minus is going to be less than 1 plus a value on here. So I know that when I'm separating this out, they're going to appear in this order, right? The 1 minus square root of 13 over 4 is going to be lesser. Okay. So I've got my 3 sections where these numbers right here are the dividers, right? To help me make a good decision of what numbers I can use, I'll go ahead and punch them up real quick to see what their decimal values are. Let's see, 1 plus square root of 13 divided by 4. I got 1.15, so about 1.2-ish. B is approximately 1.2. And change to a minus. A is approximately negative 0.65, so 7. Okay. Now again, I don't need those for the actual writing out the answer, unless it's one of those applications where you need that. But in this case, I'm going to be as accurate as possible by using these still in the answer. I need these so that I can make sure that I'm making good choices as far as what numbers to pick in these intervals. Okay, so right here, negative 0.7 is where A is. So that means I can pick anything in this interval between negative infinity and say negative 1. So if I pick x equals negative 10, right, then I'll be well within underneath the negative 0.7. Okay, so then if I plug in negative 10, I've got 400 minus 3, 397, is greater than negative 20, right? 2 times negative 10, which is completely true, right? So this is a good interval. Next, A is negative and B is positive, which means 0 is perfect for the picking in between them, right? A is negative, B is positive, so I can pick 0. Okay, if I plug in 0, I've got 0 minus 3, negative 3, is greater than 2 times 0, which is 0. A negative number is not greater than 0, so it's a big old false, right? Don't use this section. Okay, and the last section here is anything bigger, anything greater than 1.2. So that's easy to pick 10. 10 is definitely greater than 1.2. Okay, so if I plug in 10, again I get 400 minus 3, 397, greater than 2 times 10, right, is 20. The only difference is, the sign on this one. It's still true though, so I can still use that section. Okay, let's write the solution set here. So I'm going to be going from negative infinity, because that's this section here, all the way up to A. Now A was this one, 1 minus square root of 13 over 4. Okay? No equal signs, so parentheses. Union with, here I've got B to infinity for that other section. So B is here, 1 plus square root of 13 over 4, all the way to infinity. Okay. So you don't always have to be able to factor. The key to the factoring was to make the solving portion quicker. But if you can't factor, but you can still solve the equation part, you're still golden. One more example. It's entirely possible that our inequalities may also have rational expressions in them, right? In this case, the fraction x over x plus 2. I still am going to work this the same structural way. I'm going to try and get my 0. I'm going to factor everything out as possible and try to get these little grouped objects. The one extra thing you have to remember is that no matter what, negative 2 is not allowed in the solution set, because negative 2 causes a division by 0 when you plug that number in for x. Okay, so let's keep that in the back of our minds, and even at the very beginning, if you want to remind yourself, x can't equal negative 2, right? However, I will still use negative 2 as a separator, right? You'll see in a minute. I'll show you how we can do that. Okay, so first step, right? I want to get 0. That means I'm going to subtract the 2 over. It's not going to immediately combine though, because I don't have a common denominator, right? To get a common denominator, I'm going to have to multiply top and bottom here, numerator and denominator, by the x plus 2. Like so. Now the denominators are equal. I'm going to distribute this negative 2 into these parentheses and combine the numerator. So that's going to look like this. X minus 2x minus 4 over x plus 2 is greater than or equal to 0. And then x minus 2x, I can get negative x minus 4 over x plus 2 is greater than or equal to 0. Okay. Now, whenever you have one of these rational things that I need to solve for, I'm going to do the equals 0 portion. And what I'm going to do is I'm going to do it to both the top and the bottom. Okay? Now, I know typically that's not what you do with a rational expression. Okay? But each piece from the numerator and denominator can contribute a separator number. Okay? So what I'm going to do is I'm just going to take them separately. I'm going to solve negative x minus 4 equals 0. And I'm also going to do x plus 2 equals 0 Not that this can actually happen, right? We've already said, and actually I've already found that number earlier when we were talking about what x can't be, okay? So as a big old reminder, I'm only doing this to find the separator number, okay? I'm not actually using -2 as a solution. Okay, so I found one of my separator numbers right there for that. Next, right here, if I just add x, I get x is -4. Now, is it always going to be that straightforward in these kind of things? No. Your numerator and denominator could each have quadratics in them or other objects in them, whatever. Okay, so it's very, very possible that you could have more work to do here. It's just that this one happened to work out where my numerator and denominator were quick linear solves. So I have two different separator numbers. I'll draw my number line out, and I'll put them in numerical order, right? -4, then -2. And I've got my sections. Okay, so now let's test it. In this first section here, I have anything from -infinity to -4 that I can pick. Okay? Well, maybe I'll pick my favorite, right? -10. Easy to plug in. Okay? So we go back to the original, remember? I've got -10 over -10 plus 2 and greater than or equal to 2. Okay? So that's going to give me -10 over -8, which I can reduce. Double negative is positive. 10 over 8 reduces to 5 over 4 is greater than or equal to 2. But remember, 2 is 8 over 4. And 5 is not greater than 8. So this is a big old false, right? Don't use this interval. Between -4 and -2, I'm going to pick, I don't have any of my nice numbers to choose from. I really only have one integer to choose from, -3, right? So that's going to give me -3 over -3 plus 2 greater than or equal to 2. And that gives me -3 over -1, which is 3. And that's completely true, right? Positive 3 is greater than 2, so we do have that middle section as part of my solution set there. Okay, and then the last section here, I'll pick x equals 0, right? 0 is definitely between -2 and infinity. So then I've got 0 over 0 plus 2, right? That's 0 divided by 2, but 0 divided by anything is 0. And this is completely false, right? So don't use this section either. So my solution set must be only coming from the middle section. But don't forget, we had an equal to in here, right? Which means I can use brackets on certain things. Here's the reminder. -2, even though it's a separator, cannot be part of the solution. That would cause division by 0. So here's my solution set. Okay? X is going to be an element of bracket -4, -2 parentheses. I'm using that interval. -4 can be given an equal to, a bracket, right? It came from the numerator. But -2 cannot be bracketed. It cannot be included. It's only a separator, not an actual part of the solution. Okay? All right, so I hope this helps you in learning the skills of solving nonlinear inequalities.